So hello everyone, myself Kunal, and I'm your physics tutor, and we're actually doing ray optics and optical instrument, and today is our second lecture on this topic. So let me quickly recap the things कि हमने previous class में क्या क्या चीजें cover करी थी. So I have to choose the okay. So let me quickly recap the things कि हमने previous class में क्या क्या चीजें cover करी थी. So हमने previous class में मेजरली हमने क्या क्या करा था. सो वी विल एक्चुअली डिस्कस अबाउट द थिंग्स लाइक ऑप्टिक्स में हमें क्या क्या चीजें पढ़नी है. तो हमने बात करी थी इट्स लाइक टू काइंड्स, वेव ऑप्टिक्स एंड द क्वांटम ऑप्टिक्स, राइट. फिर इसमें हमने देखा था कि क्या क्या चीजें हमें पढ़नी होती हैं. तो हमने एक लिस्ट बनाया था, राइट, लाइक रिफ्लेक्शन, रिफ्रैक्शन, डिफ्रैक्शन, इंटरफेरेंस, right, and photoelectric effect and all, right. It's 7 or 8 kind of thing that we have to read in this chapter. Then we move to the next part, which is actually our first part, which is actually reflection. हमने रिफ्लेक्शन कवर करा था. इसमें हमने डिस्कस ये करा था कि irrespective of surfaces, either it will be a plane surfaces or it will be a curved surfaces, our laws of reflection, which one is like angle of incidence is equal to angle of r, and incident ray, reflected ray, and the normal lies on the same plane. These two laws is valid everywhere, irrespective of the kind of the planes. Either it will be a planes, normal planes, or it will be a curve, right? It will be valid everywhere. So in today's class, we are going to discuss about the reflection at plane mirror. So I hope you all is aware what is plane mirror. Basically, it's like जो आप शीशे को बोलते हो ना, तो सेम थिंग, लाइक इट इज एक्चुअली प्लेन मिरर. सो लेट मी क्विकली ड्रॉ द थिंग्स. लेट मी टेक सम like red color as a surface, okay, and with white color as an incident. I have to draw normal as well. So, and this is actually our normal. We have to take cylinder. So let me draw the normal here. This is actually our plane. So actually this is our normal, and now I have to insert incident light here. So if I didn't select that, so this is our actually incident ray of light, and another thing that I have to take is reflected light. Okay, I hope that is fine now. Okay, so this is actually our plane mirror with this is actually front part and this is actually back end. This is actually representing the silver coating, and this is actually our incident light. This is actually our reflected light, right? Now, what I'm trying to tell you is here actually law of reflection is valid because obviously it's a plane surface. Actually, irrespective of the surface, laws of reflection valid. So this is actually our normal. This is actually our मैंने previous class में दिखाई थी. So I'm just going to like this is our angle of incidence and this is actually our angle of reflection, right? So here the things is we have to discuss some of the topics here. So let's start. The first thing is what is actually plane mirror. I have to choose I think different color because it's let's choose the white. Okay. So what is actually plane mirror? So this is actually plane mirror, right? So plane mirror is a thin glass plate which is actually polished at the one surfaces, which is actually silver coating, right? So let me write it here. What is plane mirror? So a plane mirror is a thin plate of glass, a thin plate of glass polished at one surfaces, right? So this is actually the plane mirror is. So in which one surface is actually polished and it is actually by silver coating, right? So let me draw it here. If this is our actually glass plate, I'm actually zooming the same thing, right? I'm just zoom this same figure. Zooming actually, you know. So this is actually our glass plate and this is actually our shining surfaces, and back end if you look at the plane mirror, so there is actually polished, right? So now the things we have to conclude it from here, from plane mirror is like in previous class, we are actually deal with some of like normal incidents, grazing incidents, right? So here the same thing we are dealing with the plane mirror and we are defining those terms as well. So the actually the term is normal incident. So when the ray of light, when the ray of light is actually incident through the normal, right? In like this is actually our incident light, right? So the ray retraces its path. So basically, here the angle I is equal to 0, and we all know that from laws of reflection, angle actually incident angle is equal to reflected angle. So angle R is also equal to 0. कैसे हुआ? Because angle I is equal to angle R. Angle of incidence is equal to angle of reflection. In this case, what's happened? In this case, what's happened? In this case, actually, a ray retraces its path. If you look at from here, so what I'm trying to say, if this is actually our plane mirror and this is actually our normal, and from there, if the ray is incident on the plane mirror, so if this is actually I, this is actually reflection. Ray retraces its path, right? This is our actually plane mirror. So this thing actually happening, right? And angle of incidence is equal to 0, angle of reflection is equal to 0. And this point you have to remember, if the angle of incidence is equal to angle of reflection is equal to 0, so the ray of light is actually retraces its path. Now let's move to the second thing, which is actually grazing incident. So what is actually grazing incidence? If the angle of incidence is actually 90 degree, so according to the laws of reflection, angle of reflection is also 90 degree. So basically what I'm trying to say, if our angle of incidence is this, like we are actually measuring the angle of incidence and the angle of reflection from normal. So what I'm trying to say is if this angle is 90 degree, that means our angle of incidence is between incident ray, the angle of incidence is like the angle between normal and the incident ray. So this angle is actually 90 degrees. So this ray is actually passing without any kinds of, actually without changing path, right? So angle I is equal to angle R is equal to 90 degree. So there will be, so there is no change in path. That means if I, this is actually our normal. So if ray of light is incident in at angle of incidence 90 degree, it just pass through without changing path. So these are some special cases. If the angle of incidence, angle of reflection is equal to 0, then the ray of light retraces its path. And if angle of incidence is equal to, and if angle of incidence is equal to angle of reflection is equal to 90 degree, so the ray of light is actually passes without any change in path. Now the third things we have to discuss about the deviations in a reflection through the plane mirror. Deviations in reflection through plane mirror. Okay, so if I'm gonna tell you, let's watch this. Let's watch this video. Our ray has to be moved in this direction, right? This straight direction. But what happened? Actually, our ray of light is deviated through this angle. If I'm called it as delta, this is actually representing the uh, angle of deviation, right? Actually, I'm incident the angle at some angle of I, and actually the ray has to be moving this straight direction, right? But actually the ray is bend in the same medium with change actually with actually there is a change in path of the incident light in the same mediums, right? Actually the ray of the incident ray of light has to move in this direction, but actually it's moving in some other direction. So what is the actually deviation? So this angle is the actually angle of deviation, right? And this is this and this angle is equal. So what we can do, we can do one more thing. If I'm gonna talking about, let's call it as LPQ. So if I'm talking about the straight line LPQ, so the sum of all angle is actually is equal to 180 degree, right? So what I'm telling is angle I plus angle R plus angle of deviations is actually is equal to 180 degree. I'm talking about the straight line from straight line LPQ, I think it is. Yeah, it is LPQ. So I'm talking about from the straight line, look at here. Angle of incidence, angle of reflection plus deviation angle is actually equal to 180 degree, right? So what I'm telling, this and this angle is actually same, so we can call as twice angle of incidence plus angle of deviation is equal to pi or 180 degree, whatever you want to say, just. So the angle of deviation is actually is equal to pi minus 2i, where I is actually angle of incident. So one thing you have to notate here, I am considering that the angle of deviation in anti-clockwise direction, right? Anti-clockwise direction. Okay, so now they'll give me a noted point here. Always uh, think the angle of deviation is in anti-clockwise if nothing is given. Now, what is actually del? So let me write it here. It is the angle between subtended incident ray and reflected ray. Okay, so it is the actually angle between the subtended incident ray and the reflected ray. This is actually the angle of deviations here, right? So now this is the thing that we are talking about, the plane mirror. So plane mirror क्या होती है? So it's actually a thin piece of glass जिसमें एक surfaces coated होता है, which is actually silver coating, and the other surface is actually shining. So we are actually considering here the laws of reflection, and we are applying the laws of reflection here. So what we get things. So what the things we get is actually we derive some terms like normal incidence. And so the normal incidence is like when the angle of incidence is equal to angle of reflection is equal to 0 degree. And in this case, actually a ray of incident light retraces its path. And the next thing we are actually dealing with the term is grazing incident. So in grazing incident, angle of incidence is 90 degree. So from laws of reflection, angle of reflection is also 90 degree. In this case, the ray of light just passes through without changing its path. And the next thing we are dealing with the term is like deviations, angle of deviations. So it is the angle of the deviations is defined as like it is the angle between the subtended incident ray and the reflected ray, right? So, and I derive it, and it is actually equal to pi minus 2i in anti-clockwise direction. So let me write it here. It is in actually anti-clockwise directions, right? So this is the thing that we have to do. Now, what you have to do it here, you have to draw the graph. You have to draw the graph between angle of deviations and the incident angle. So let me write it here. We're actually deal with the graph kind of thing. So, okay. So draw the graph between del and I for plane mirror, right? Okay, so look at here. We have a relation like angle of deviation is equal to pi minus 2a, right? So this is actually the representing kind of straight line, because if we are comparing this with like y is equal to mx plus c, so our graph will be something look like straight line, and it is actually, let me draw it by this. Why I'm doing so? Let's insert a straight line as well with some other color. So I have to insert a straight line. Okay. I hope that's it. Okay, so this is actually our angle of deviations, and this is actually our angle of incidence, and this is actually our phi. So angle of incidence is uh, obviously when the angle of incidence is 0, its value is pi, and when angle of incidence is pi by 2, its value is actually 0. Right. So this is the actually graph between via this relation we concluded the graph between the del and angle of incidence. Right. Now we have some kind of questions here. So let's try to find it out. We are dealing with some problem. So let's take the question number 1. Let's insert here something. So let's take here the straight line. Let's take here the another straight line. I hope that is fine now. So this is actually the two plane mirror, and both plane mirror is actually at an angle of 60 degree. And this is actually plane mirror 2, which has one part is quoted and another part is shining. And what I'm gonna do here is I'm taking an incident ray of light here from here, and this angle is actually given as 60 degree. So you have to find deviations, angle of deviations, obviously. Okay. I hope this question is clear to all of you, and let me call it as this mirror is actually M1 and this mirror is actually M2. So let me first explain the questions here. So there is actually two mirror which is named as M1 and M2, and both is actually inclined at the angle of 60 degree, and there is an incident light which is actually making an angle of 60 degree with the one of the plane mirror, which is actually M1. So then you have to find the net deviations, right? So how can we do this? So we have actually formula. The deviation is equal to pi minus 2 times of angle of incidence, right? So let's apply this formula. And we have actually shortcut kind of things also. So we are dealing with it in sometimes. So first try to find it by the original method that we have. So let's take by the first mirror we have a deviation kind of del 1, and by the second mirror we have a deviation kinds of del 2. So the actually del 1 is equal to pi minus 2 times of angle of incidence. So pi minus, we have a, let's draw the normal here, right? So when you draw the normal, this is actually 60, so this is actually 30 degree. So we all know that our ray of light is actually some kind of things like I'm talking about is, this is actually 30 degree. From angle of incidence is equal to angle of reflection, right? And now from mirror to, when you draw the uh, normal here, so what I'm gonna taking about is this angle is 60 degree, so this angle is 60, so this angle is 30 degree. So again there is a reflection by 30 degree, so this angle is again 60 degree, right? So what I'm gonna talking about is this angle is actually 30 degrees, so pi minus 2 times of 30 degree. So there's like 120 degree की deviation से किस direction में? In anti-clockwise direction. Now the next, in from mirror to, we have again the pi minus 2i kind of deviation, because angle of deviation formula is nothing but pi minus of 2i. So there will be like 180 degree minus again the deviation by the 30 degree, so it will be like 2 times of 30 degree. So it's again like 120 degree, again in anti-clockwise direction. So net deviations is actually is equal to del 1 plus del 2. So its value is equal to 240 degree in anti-clockwise direction. So this is actually the things that we are Okay. So what you have to do, you have to just uh, take the incident ray of light and just apply the formula. The things is, the first thing is actually given is between the angle between incident ray and the mirror. But we have to find the angle of incidence, which is actually between the incident ray and the normal. So I draw the normal here and I find the incident angle, which we found as a 30°. And then we use the property of triangle. So it is actually equilateral triangle, 60, 60, 60. So again, the angle of incident is become the 30° for the mirror too as well, right? So we have actually a net deviations of 240° in anti-clockwise directions. Now what we have to do, we have to take some kind of special cases in deviations, right? So let's take this time is as this is actually the let's special cases on deviations. So what I'm gonna take here is I'm actually taking a plane mirror, and this is actually our normal. This is actually our incident ray of light, and this is actually our reflected ray of light, right? If rotation in incident angle by theta, let me call it as if I rotate this angle as theta. So find the angle moved by the reflected ray. Take it as a question. If rotation in incident ray by theta, so angle moved by reflected ray is right. So actually it is if you rotate the angle by the theta, it's also rotated in the angle by theta because we have to maintain the laws of reflection, and it's stating that the angle of incidence is actually equal to angle of reflection, right? So if you uh, rotate the incident angle, incident ray by theta, so our reflected ray is also rotated by angle of theta because we have to maintain the laws of reflections, right? So, but there is the things like rotation as to maintain the as to obey the laws of reflection, the rotation is in opposite direction. If you rotate the angle of incident in clockwise direction, so angle of reflection is actually rotated in anti-clockwise direction. So rotations in this is actually you can call it as case A. So rotation in reflected ray is equal to theta, but it is in actually in opposite direction to incident ray. So let me draw a table, simple table here. You can easily relate it with. So this is actually angle I, this is actually angle R, and you are actually rotating I by theta. Now there is like if you rotate it by anti-clockwise direction, let me use here the abbreviation ACE, that means anti-clock, and C, that means clockwise. So the angle of reflection is actually in clockwise direction. And if you rotate the angle of incident in clockwise direction by theta, so angle of reflection is rotated in anti-clockwise direction, right? So this table that you have to keep in mind. So in this case, we are actually rotating the incident ray. What happened if I rotate the uh, reflected ray? So it will be same. If you rotate the reflected ray, so incident ray will be also rotated by the same angle, but in opposite direction, right? So let me write it here. either you can rotate the incident ray or reflected ray by an angle of theta in AC or C direction, or thus will get rotated in C by AC direction respectively. I hope this will be clear to all of you, right? चाहे आप रिफ्लेक्टेड रे को रोटेट करो या इंसिडेंट रे को रोटेट करो, इट विल बी लाइक अगर आपने रिफ्लेक्टेड रे को रोटेट कर रहा थीटा एंगल से, so our incident ray also varies by angle of theta but in opposite directions. Now let's take the cases B. What is the actually the if I rotate the mirror, this time I rotate the incident ray, right? Right now what I'm trying to say, this is actually our mirror, this is actually our normal, this is actually our incident ray, and this is actually our reflected ray. Now in previous special case, what I did, I just rotate the either the angle of incidence or the angle of reflection, either the incident ray or the reflected ray. Right now what I'm trying to do here is I'm just rotating the mirror by an angle of theta. Now I have to find the rotations in reflected ray and deviations, right? So okay, let me draw it here because clearly I have to draw. So let me take a simple color and I have to insert I have to make a clear diagram here. Okay. So actually I'm assuming this is actually our original plane mirror and this is actually our normal. Okay, that's fine. I hope it's not. Okay, so this is actually our normal. Okay, and this is actually our incident light. This is actually our reflected light. Okay, and what I'm now doing, let me take with some other color. Let me take it with kind of light. So what I'm doing now, I am just what's happened. I have to take a blue color, right? So what I did, I have to just rotate the mirror by an angle of theta. Don't worry, I'm gonna tell you each and everything. So actually our normal is also varying and normal is also shifted by the angle of theta. So this is actually our, let me cut it and again I have to do. Okay, so this is actually our normal for the rotated mirror, right? And similarly we have incident ray and the reflected ray for the each and every one. So let me draw it here. So it will be something like this. And this is actually our reflected ray. Let me write it and note each and every one so it will be clear to all of you. Don't worry. So this is actually our, let me write with an original. This is actually our plane mirror original. And this is actually our incident ray original. This is actually our reflected ray original. Now this is actually our plane mirror rotated PR. That means plane mirror rotated. This is actually our IR, basically incident angle rotated. This is actually our IRR, you can say, right? Reflected. And this is actually our normal of reflected plane mirror, right? Now what I have to do, if I rotate this plane mirror by an angle of theta, this angle is also theta. right? And let us suppose our incident angle is actually rotated by some angle of x, right? And normal is also shifted by theta, because the whole plane mirror is rotated by the 90 degrees. So the normal is also rotated by the 90 degrees, right? Now, let us assume that this angle is actually uh, from the incident angle is actually x degree, right? If I'm assuming that this is actually x, because we didn't know by how much degree angle of incident varies, right? So if this is x degree, uh, right? So there is actually the deviations kind of thing, and this is actually our x minus theta. This angle is actually x minus theta, because we have to maintain the angle of incidence for is equal to angle of reflection for the laws of reflection to be valid, right? And this is actually our deviation del. And we all know that from here, like x plus theta is actually equal to x minus theta plus del. What I'm just doing here, I'm just doing I is equal to R. R is equal to RR, laws of reflection. I hope it will be clear to all of you, right? This is actually our normal. Now, this is actually our incident angle, x plus theta. So our reflected angle also should be equal to x plus theta. So I'm just doing x plus theta is equal to x minus theta plus del. So what I'm getting here, I will be getting del is equal to 2 theta. If you solve this equation, you will get the angle of deviation is equal to 2 theta. That means you have to note here is, you can say like angular frequency, angular velocity of rotated mirror is actually is equal to 2 times of omega of mirror, right? You can say in this world. I hope it will be clear to all of you. You have to find the angle of basically if I rotate the mirror by the theta angle, this is actually our red color. Let me note here. Red is actually our original mirror, and blue is actually our rotated mirror, right? So if I rotate the angle by rotate the plane mirror by theta angle, so how our angle of incidence and all changes, I don't know, but we have to calculate this. So I'm just applying the angle of incidence is equal to angle of reflection, which is actually laws of reflection. So I get incident angle is x plus theta and the reflected angle is x minus theta plus del. So we get to the relation like angle of deviation is varying 2 times of angle of angle of rotations, right? So this thing that you have to keep in mind. So these are the two cases that we are dealing with. So actually that's all for today's. In tomorrow's class, we are gonna deal with some problem first based on the above cases. And then we are gonna discuss about some images and object kind of things. Thank you.